All right, more on Math 5130. We're going to get into sampling today. So let's just, this video is really just more about uh, some sharing some sampling methods and just becoming familiar with some vocabulary and terms. I don't think anything from this video will be straightforwardly tested or show up on, it may show up on an assignment, but these are things you just need to have tattooed to your brain and be aware that there are different types of sampling that we encounter. So the first thing, and I'm sure everyone's heard of a placebo, kind of called the gold standard. And placebo is, as we say here, it's a harmless and ineffective pill, but it gives us kind of a baseline for determining if another type of medication is effective. Basics of collecting data. A couple of things I want you to have on your radar is the difference between an observational study and an experiment. And you'll notice through these videos that I really don't go into a lot of depth because, and the reason is because I think students today, professors today, including me, we almost have the world at our fingertips. If there's something that I need on a whim, I need a definition of stratified sampling. I may not have that, quote unquote, tattooed to the brain. So I just jump on Google or whatever search engine that you use and just type it in, and you get a definition and examples very quickly. So I guess the purpose of this video is to point out the terms and data collections that I think are important and that I think you need to have on your radar. So observational study, experiment, those are pretty straightforward. An experiment is where we have something and then we apply a treatment and then we measure that something a second time to see if the treatment was actually effective. For example, maybe someone has a group of patients have high blood pressure, and a treatment may be maybe an exercise program or a medication, whatever it may be. That's our treatment, and then afterwards we would measure the subject again to see if the treatment was effective in lowering blood pressure. And, this kind of stuff shows up all the time in health sciences. An observational study, I think of this kind of a lazy person in a way. You kick your feet up and you pop back and you just observe a bunch of stuff going on in front of you. You may observe behavior. Again, there's all kinds of different ways that you can implement an observational study within a healthcare facility. Design of experiments, and we'll go through 4 here. Replication is the repetition of an experiment on more than one individual. And, again, with replication, adequate sample size is, and that's, needed. That's an interesting question. What is the, we're going to run into this later because we'll get into power analysis and effect size. But what is an adequate sample size? Well, really, it just depends. I've seen studies where 30 was enough. I've seen other studies where we needed 350. I always say, if you're going to work for BMW or Porsche or whatever, Mercedes, you have to work with small sample sizes. You can't go to the CEO and say, hey, why don't you give me 300 of those BMW X5 so I can go ahead and run it and crash it into a wall and analyze the crash data. You might have to make decisions based on 1 or 2. So it just depends on the nature, but and it depends on the statistical technique that you're using. Blinding, we've probably all heard of this. I think of blinding as kind of the placebo effect. Blinding, technically, is just where the subject doesn't know if he or she is receiving the treatment. Double blind is where blinding occurs at 2 levels. The subject doesn't know and the experimenter doesn't know. Randomization, this is where we have where subjects are assigned to different groups. Uh, the logic behind randomness is to use chance as a way to create two groups that are similar. So, that would be if you had a bunch of people who are have high blood pressure again, and you want to implement a treatment versus a placebo. Well, you would randomly select the people who got the placebo, and you would randomly select the people who got the treatment. So that's what is meant by randomization. Simple random sample, we sometimes call that SRS. You'll notice statisticians aren't too clever or creative. Simple random sample, SRS, obviously why. And that's where we have a sample of N subjects where every possible sample or subject has an equal chance of being selected. So again, I kind of stumbled through that. Random sampling is just the process of selecting your samples such that every single subject, element, cat, dog, whatever it may be in your population has an equal chance of being selected. And that is the best way to reduce bias. Again, bias is a deviation from the truth. It's a deviation from what is actually occurring and what our sample data actually indicates is occurring. Again, the best way to, and obviously it's important because I'm repeating it, the best way to reduce bias is through a simple random sample. And you find, I'm in journal articles in all kinds of different fields, and you find very, very rarely do studies actually work with a simple random sample. So maybe that's something that'll be on your radar now when you look at articles within your field, and how much credibility that you give to the results of a journal article or a study. Was the sample truly representative of the population from which it was drawn? Systematic sampling, I think maybe in the healthcare industry this would be okay. That's just where you place things in a line, and you choose maybe every second or every fourth person to be part of your sample. I think this is, again, probably okay with people. I really have a problem seeing this implemented in a manufacturing process, because sometimes I've seen with machines, sometimes you have machines that would create like a defect every, nth time, every fifth time, 10th time, 12th time, whatever it may be. And if you just so happen to choose the kth element in the population, then you're going to get overrepresented number of defects. I hope that makes sense. But in the healthcare industry, I don't know that systematic sampling would necessarily be a bad thing. It's not as good as random sampling, but it's better than some of the other things that we'll look at. Speaking of, perfect segue, convenience sampling. That's just something where you go into the lunchroom one day and there's a bunch of healthcare professionals there, and you think, well, hey, I can get an easy sample. I'll just ask them or give them this survey or questionnaire. They're easy to get. Unfortunately, convenience sampling is really problematic when it comes to generalizing the results to a larger population. So, it could be a healthcare facility you're trying to generalize to. It could be healthcare facilities within a particular region or state, or even globally or nationally. Stratified sampling is kind of interesting. This is where you'd subdivide the population into at least two groups, and then you dive in and take samples from each. In a healthcare facility, I think what would make sense there is maybe divide the population into 4 subgroups. Subgroup number 1 would be doctors, subgroup number 2 nurses, maybe allied health professionals as the 3rd, and maybe support staff as the 4th. If you're implementing stratified sampling, then you would go into the doctors, all the doctors, and you would randomly select some, and then you would randomly select some nurses, and you would randomly select allied health professionals, and then randomly select from your support staff. So that's an example of stratified sampling. Closely related to, but completely different, cluster sampling. Cluster sampling is where you divide your population into clusters. Again, I told you statisticians aren't that clever. So, or well, I don't know if we're clever or not, but we're not that creative. Think of cluster sampling as, let's say that there's a particular region, and let's say there are 12 healthcare facilities within that region. So what I would do if I was going to implement cluster sampling in a study of this nature is I would take a random sample of the 12. Maybe I set out to collect data from 5 of them. So I would what I do a lot of times is in getting a random sample, if my daughters are here, my wife, whatever, I'll say, hey, I've got numbers from 1 to 12. Choose 5 numbers between 1 to 12, 3, 7, 9, whatever. And that becomes my random sample. So I would take those healthcare facilities that I had pre-numbered and develop my study from that. All right, gang, that's all I got. Take care.